You're welcome. So now here, we need to deal with a rational function here. We cannot substitute the value -1 here directly because it will make the denominator 0. It is undefined, so we cannot do substitution directly. Okay. That is why we need to work around with this and simplify it. So let us try. Now, okay, what should we do? Any suggestion? Let us solve it together. And I will show you different ways to deal with this later. Factor the bottoms. Very good, James. Okay. Let's do it. Factor the bottoms as Jim suggests. Then the bottoms. Something square, subtract 1. And 1, we can write it as 1 square, right? They're the same things. So therefore, a square minus b square, it will be a, which is x minus 1 times x plus 1. Okay. The numerator, 2, 3, 1. It is square. So the trick, how to factor it. The trick I showed you before in class doesn't work this way because there's a number 2 right here. So should be careful. But now, so look at this. The order decreases from x squared, x, and here is x to the 0 or a constant. Let us break it. Do you have any suggestion how we can deal with this? Just guess. Wow, Olivia, amazing. You write down a perfect solution already. Very good. But can you show us the steps how you get that result?
What I usually do is I'll take whatever numbers in front of the x squared and make it like, I don't know. I usually just play around with the numbers until it works.
Yeah, it's amazing. You see,
Yeah.
here the first one has a factor of 2, right? And now 3x here. 3x, if we somehow manipulate it and write it as 2x plus x. They're the same things, right? Nothing's changed yet. But if we write it this way, then we see that we can factor this guy together and this guy's together and see. Let's try, right? If you don't see it immediately at the beginning, just practice like Olivia did, and you get an insight, intuition how to get these. Okay, now the first pair, if we factor, what is the common things between 2x squared times 2x here?
2x.
It means 2x is the common things. We can factor it out. What is left inside here?
X plus 1.
Yes. Very good. So x plus 1 is the second pair here. We just write it in this parentheses, okay? They are the same things. In front of the parentheses is a positive sign. We can just simply remove that parentheses and give it back x plus 1 here. Nothing's changed yet. The denominator x minus 1. Oh, by the way, can you see it clearly? Was a little small. Here, the denominator is x plus 1. Good. So at this point, if you want to double check whether we factor it correct or not. You just simply multiply this here. 2x times x give us 2x squared, right? 2x times 1 give us 2x. Fair. Okay, now what should we do?
Cancel the x plus 1.
Be careful. We're not there yet.
Wait, never mind. It's not multiplying. You're right.
Because there's an addition terms here, right? We can simplify it when they are all multiplication in numerator and denominator. Okay. So let us factor them out first and write them as multiplications. Then later we can cancel out. But for now, don't skip it. We may got mistake if we skip this step. So now first, these two guys, the common things of these two is this term and this term, right? Imagine in your head. This in front of that is, you can always imagine it is multiplied by 1. It's easier to factor now. You factor the common terms out, x plus 1. Multiply with a parenthesis here. Okay. Inside this parenthesis will be whatever left here, which is 2x, right? It will be 2x plus, and the second guy here, whatever left here, we write it down 1. This is exactly what Olivia typed in the chat box. Beautiful. So fast. And in the denominator, x minus 1 times x plus 1. Okay, you see that in the numerator, they are all multiplication of parentheses, everything, beautiful. And now we see that this is a like term. We can cancel out. They will disappear, right? It becomes what?
It's 2x plus 1 on top and then x minus 1 on bottom.
Thank you. Now, can we substitute the value -1 to this?
Yes.
Yes, it is a rational. It is a quotient of two polynomials or rational function, and it is defined at -1. So we can just simply substitute this here, which will be 2 times -1 plus 1 divided by -1 subtract 1. So in the numerator becomes 1 minus 2 will be -1, right? Denominator will be?
Negative.
Yes. And then the final result will be 1/2. That's it for this problem, okay? This is one way. We are lucky. Somehow we do a separation of variables here easily. Okay, I'll give you some other tricks to deal with this faster. Before going that, let me review some properties of a polynomial. So, a polynomial let us call p of x, which is a x squared plus bx plus c. Okay. It can be written as if there are two solutions, then we can always factor this polynomial as a times x minus the first solution times x minus the second solution. It is a very interesting properties. Okay. What is the formula to find x1 and x2 here? Do you remember the discriminant formula? Minus b plus or minus square root of the discriminant d over 2a, where d is for b square minus 4ac. Interesting properties. If a plus b plus c is equal to 0, then there is one solution. A plus b plus c is equal to 0. It means that 1 is a solution of this function, right? You can substitute value of 1 here. 1 squared give us 1, give us a here, plus b times 1 plus c, or in other words, if we see a plus b plus c is equal to 1, then there is a solution. x1 is equal to 1. And the second solution, x2, will be c over a. Interesting properties. If you remember it, you can do it faster. A minus b plus c is equal to 0. Remember, this is a negative sign. Then there are two solutions. What is the first one? Can you guess? Here. It is -1. And the second one is negative c over a. We can apply this to our example. Right here, a subtract b plus c is equal to 0, right? You can use the discriminant formula to find the solution, or I should have used this notation, this, or they're both, or so it means the solution will be -1. And what is the second one? Thank you. Oh, be careful. C over A. Yeah. Thank you. -1 and negative here. It is a negative sign. -1/2, right? You get, thank you. And from this properties, we see that we can always write this is a product of this parameters here times x subtract the first solution times x subtract the second solution. Therefore, 2x squared plus 3x plus 1. So according to the properties you wrote there, it is 2 times x minus the first solution times x minus the second solution. And the first solution here is -1. The second solution here is -1/2. Okay. Then let us simplify it. So it would be 2 times negative of -1 give us +1, right? And here negative of -1/2 give us 1/2, right? Is it the same as what we found? A little different. But now see that the number 2 here, we can definitely distribute this guy to the second bracket here, right? Or it is x plus 1 times 2 times x here, give us 2x. 2 times x 1/2 give us 1. It is exactly the same as what we found before, right? Previously. Here.
Oh, is that just to, or what you showed us, is that just to check like that we got the answer right? Okay.
I mean, I want to show you different ways to get the same result.
Oh, okay,
Yeah.
okay.
It is
Yeah.
also good to check. That
Yeah.
is one way. Another way, we can do long division. Do you remember how to do long division for polynomial? Huh, good job, Olivia. You impressed me. Okay, let me just review so that other people will, if they don't remember, they will be able to do it. So now, let us find the product here, a factor here. So one way, before I go to that part, if we are given a polynomial, p of x here is an x to the n plus an minus 1 x to the n minus 1, etc. a1 x plus a0. If there is a solution x is equal to something let us call b, then p of x can always be written as, we can factor this solution out, x minus b times something, a function of x here, where q of x is 1 degree lower than p of x. Now, in our case, in the future, if you don't remember, but you see something very interesting about these parameters, 2, 3, and 1, very interesting, right? 2 minus 3 plus 1 is equal to 0. So we know that x is equal to -1 is a solution. Therefore, we know for sure that x plus 3, 2x squared plus 3x plus 1 can be written as x minus the solution. Here in this case is -1, give us x plus 1 times something we don't know. Okay, we don't know here, but we can guess. Then one way to do it is to do long division. Okay, so long division, if we are given a polynomial, for example, in this case, 2x squared plus 3x plus 1, and it is divided by, we know that, okay, there's this term here. It means we are divided by this guy, x plus 1. Okay, long division, we will pick the highest degree of this one. In this case, it's x squared. We divide it by the highest degree of the divider here. We see that 2x squared divided by x, what do we have? Two x squared divided by x. 2x squared is 2x times x, right? Then x in the numerator cancel with x in the denominator, give us 2x. Okay, therefore this term, we write it here, 2x. Then we multiply this term back to the divider here, which is 2x times x plus 1. We'll distribute here and distribute here. 2x times x give us 2x times 1 give us
2x.
Thank you, 2x. Very good. Then the next step, we will subtract the whole thing. Subtract. Okay. In this subtraction step here, 2x squared subtract 2x squared give us, cancel each other, 3x here, subtract 2x give us, yes, 1x. And here there's no constant, then just pick number 1 here down. Okay. The next step. Okay, now this is left. We will pick the highest degree of this term, which is x in this case, divided by the highest degree of the divider, which is x in this case. X divided by x give us
1.
Thank you. Perfect. Then the same process. 1 would distribute back to the divider here. Traffic. Okay, give us 1 times x give us x. 1 times 1 give us 1. Right. At the end, we subtract the whole thing here, what we get here, x minus x gives us 0. 1 minus 1 gives us 0. Then that's it. We stop here. Therefore, this term should be 2x plus 1. This is how we deal with this is how we do long division. Okay. Do you want to practice one more with this long division but higher degree? Thank you, Olivia. Okay, or we can stop here.